Hi, everyone. What I'm going to try to do in this video is walk you through the process to complete this 3D printed toy from kind of where you're at now to all the way to what is going to be our semester final, which will be your 3D printed toy. I'm going to switch screens here and show you a presentation here that I want to walk through. All right, so really what we're going to do is go from sketching all the way to the 3D printing process and the final toy, whatever your toy happens to be. So remember, you have requirements. The toy has to have a minimum of 5 parts. There needs to be 2 different types of parts, and they must rotate. So those rotations or connections also must have 2 different types of connectors. So how they attach, fit as an assembly, and then how they rotate must employ 2 different types of movement and 2 different types of connectors. You can't use the same type of connector for all 5 body or all 5 parts of the toy. The maximum size is 6 inches by 6 inches by 6 inches. Obviously, it has to be 3D printed. The parts have to be assembled. In other words, you'll print them individually and assemble it together. You're going to need to have sketches, and that's what I'm going to spend a lot of time on today, is the sketches with dimensions and details. There's also things like you have a theme. You need to talk about the color pattern, the target age, that type of thing. So the first thing you can do today is you should have been thinking about your toy and at least have an idea. And this form called the 3D printed toy submission form has to be completed. This is on Google and it's on Schoology, so that's a Google form on Schoology. So that's something you can do today and get that taken care of. It gives us an idea of what you're thinking before you meet with us on WebEx, and that's what's going to happen this week. One of the key things that you're going to need to get done this week is to meet with your teacher on WebEx so we can discuss your toy, help you think through some of the issues that might come up, and help you out with that. So this form is one of the things you have to turn in before that meeting, and the sketches are the other one. So this is the process I would suggest. A lot of you know I build and design outside of school for a business, so this process I've been through a lot. So this is my suggestion. You don't have to follow it, but you do have to produce the sketches. So this is how I would suggest doing this. I would start by sketching the whole toy. Now I'm going to show you a quick example. I didn't put a lot of time into this because I'm not actually making this toy, but it's a simplified example of how sketching helps flush out ideas, issues, design improvements or changes you need to make before you even get to the point of working in Onshape or 3D printing. Here's my sketch. Yes, it's not beautiful. And again, art isn't what we're grading here. So the sketch is a truck, somewhere between a hauling truck, a dump truck type of thing. But I think you get the general idea. So I went from this sketch and I just started showing how the next thing you're going to do is decide which parts you're going to make. So I've kind of color coded this. I've also, so you can see here, I got a truck box. I have a cab in yellow. The frame down here is in purple. The wheels in green and the bumpers in kind of a pink color. I also have started to sketch it from different views. So this is a side view. This is a front view. And these help you look at the toy different ways. So you start thinking about different things, you know, spatial with how high the tires are fitting compared to the frame, that type of thing. So it's important that you take care of that and draw from different views. Okay? So you need a side view, front view, rear view, those types of things. Then the next thing is you're going to start breaking this thing apart and drawing or sketching the parts. So what I did first is I started with the box. I broke it apart. This is a view from the top. So if you're looking down on it, it has 2 panels up here. I'm thinking on this side view of the box, I'm thinking that those panels will slide along here. You can kind of see my arrows here if you can. So this panel will slide back and forth. So you can open and close the top of the box right up here. Okay. Also, it starts to get me to think about how and where. So I'm going to have one movement of this box opening up. So there's like a pivot hinge here. And I've kind of written that down. So a lot of the things that happen once you start doing the parts is some other ideas and considerations come out. So by sketching the part, in this case, the truck box, I started looking at it from a top view, a side view. You start thinking about how those attachments work and how they're going to move and what you need to do to make them move. And then later on, I'm going to draw a little bit more detail of those attachments. So this attachment here, and how the movements and what considerations need to be put in place. But these are all just ideas. They may change. Again, this is just the beginning. And I also write myself notes, like what type of, connections or assembly brackets or connectors I need for each of these. So now I start going through the parts, and I'm going to move through this fairly quickly because I think you get the idea, but I want to talk through some of the things that came to my mind while I did this. So the cab was next. You can see I made a mistake here. I started drawing. I didn't like it. I just crossed it out, which is perfectly fine in a sketch. Okay, so the cab is here. It sits on the frame. It's got to be attached to the frame. So I got, again, maybe snap fit down here. I also considered putting a door in here, and those are hinges on the door. So that would be another type of movement if I can get the door to open. So whether I use those or not, doesn't matter. I'm just writing ideas down and trying to get some things flushed out that I can figure out which is going to be the easiest to use and which are actually going to work. So again, these things all start to come into play with the different parts, and that's why I write down little notes to myself for each of these different parts to my truck. Then the pink part is the bumper, and that's pretty simple. So I just threw a side view of this. Again, you might need more views of this, and you'll see some later. I didn't put a lot of time into these things because this is a simplified version of that. But I have a bumper in the front and a bumper in the back. And again, I have a snap fit I wrote down, little pegs that'll push in, or a press fit possibly you could do as well there. Something simple to get it in. The bumper's not complicated. And it's not, I'm not going to have it move or anything. Then here's the wheels. So I started drawing this. Again, I started thinking about I might make a two-piece wheel, different colors, which would be kind of cool, give it a little more texture. So this might be black on the outside and some other color for the rim. And then they would press fit into each other. And so I could print them at 2 different times. Here's a front view of the same wheel with some tread patterns on it. Again, the axle I'm thinking might, again, just either snap fit or press fit into here. And again, I've talked about a couple different, hinges up here, press fit, snap fit. And I'll talk about some more different. So these are just ideas of how I might assemble different things. If we go on to the frame, which is the purple part here, a pretty straight piece, but I started looking at it from a side view up here. Now I'm down to looking at it from a top view. And as I put the wheels and axles on, I started realizing I'm going to have a problem if I have this hinge point here to tip the box and the wheel right below it. So I thought in the middle of this attachment here might have to fit in an opening. So I wrote myself an open area for the box pivot. Later on, you'll see. The other thing that I realized is I wanted my box to be bigger than the truck. So if you look over here, you'll see I've changed the drawing of the truck from the front view, which is perfectly fine. I started adding some more details. I put the bumper on. I made the box bigger and wider. Okay. Over here, the frame is on a side view. And I tipped it on edge. I just tried to fit it on this paper. I have holes for the axle. This is the front bump out, which is right here. This is the open area, which is right here. And again, I wrote box pivot area, in this open area, just reminding myself of that. And then this is really a view of the whole thing. So now it gives you an idea. And again, these could normally be on multiple papers, and I have other sheets. But I've considered all these things, and they start to make me change the drawing and write down other things, other notes that are important here. But that's kind of a sketch. And again, we're not interested in how artistic you are as long as you convey the idea. That's really the point. Then the next thing I really focused on was looking at pivot points and how this thing's going to move. So I moved a couple things. You'll see that I went to a more narrow bracket that holds the box, and I slid it to the back because I started thinking as you move this thing up, the back of the box right here would hit. So I had to slide it to the back, and I made myself a note there. I also thought about a semi-ball and socket fit right here as an attachment that would be on the bottom of the box, that it would just snap in. This half round area would snap in there. So again, these are all just considerations that help me look at different ideas and make sure I'm getting the right considerations before I even try to design this in Onshape. This is the assembly or the attachment of the bumper. This is a front view, pretty straightforward. I just left where the snap fit holes would be, and then in the frame I'd have to make allowances for that, and I'd have to create tolerances between the two. They cannot be the same size. They have to allow that. They won't fit if they're the same size. So these are all details, not only about movements, but about attachments, and then writing myself, notes that remind me of what I was thinking or things to consider when I'm drawing in Onshape or designing in Onshape. Then we move on, we need to add dimensions. So your sketches are going to have dimensions. So you can see I went back and added dimensions on here. I'm not going to talk about those much, but this gives me an idea. I made my whole thing 6 inches, which is the max it could be, and then started drawing things proportionally about what I was thinking I was going to design it as. So all your sketches need to have dimensions. So the key points here is that I would start with the whole toy. If we go kind of in review, I would make sure that you have front, rear, and side views. I didn't draw a rear view of those things, but you got the idea, I think. So make sure you have different views of the whole toy from the start. You know, again, don't worry about how pretty things are. The sketches should just convey your ideas and what type of toy, and help us be able to look at it, understand it, and then help you with it to consider other things. It probably takes several pages. I have 3 or 4 pages of sketches that I drew, even though I drew it really small. It still takes a fair amount of time, and you're going to make mistakes. You can cross stuff out. It doesn't have to be anything special. Then you need to sketch the parts and the connections and make sure they're in detail and show the movements of things. Lastly, add dimensions to your sketches and put notes on, mainly for yourself, to remind you of things to think about or things you might want to change or different ways of doing it. Then when it comes to 3D printing, so once you have the sketches done, you're going to take a picture of those and you're going to submit those. So those 2 things have to come in first, the toy submission form and the sketches, and then you can make your WebEx meeting with your teacher. As far as 3D printing, while you're doing the sketches, you're also going to be able to start printing some of the connections to prove that you can do this. So you need to submit your sketches and that toy submission form before you register for your WebEx meeting, and that's done in the office hours. And then you got to be able to prove that you can make the connections work. So we're going to focus on connections first before you do anything in Onshape to design your toy. And you cannot design your toy until you've met with your teacher. So don't start designing in Onshape until you've met with your teacher. So you'll need to design and prototype 2 different types of assembly connections. So a press fit is one I had in there. You know, you could have an axle through a hole. That's another type of movement, or a press fit or whatever. But you're going to have to print 2 of those, and you're printing just the assemblies. You're not doing it as part of your toy. You have to be able to figure out what the tolerances are. So what that really means to you is that you're going to design the connection pieces in Onshape. And you should be doing that this week, the first week that you're seeing this. Then you're going to send them to us through a form, which I'll show you in just a little bit. It's on Schoology as well, that you'll submit the STL, tell us about some considerations you need for 3D printing it. We'll 3D print it. We'll get it back to you. You can test them, see if they work, fit, pivot, rotate, whatever it is they need to do. Then likely you're going to have to redesign it and 3D print again, send the form or the STL in the form to us. We'll print it out and you'll get it back and you'll test it again. And likely this process will repeat many times. Okay. And I think if you remember from Engineering Feature 2, you had to print the hinges. It took a few times to get things dialed in, but you'll get there. So here's the submission form. You can see over here, just ask for your name, who's your teacher, adding the STL and any information there. So you can fill that out every time. It just allows us to keep track of things and make sure we get your files. We'll try to turn them around as fast as we possibly can. So a few things that you need to be thinking about as you're getting ready to design. There are many tips, ideas, suggestions, information that we covered and gave you a bunch of links to look at. And you've done a lot of 3D printing, especially in Engineering Feature 2. So I just want to cover a few things as kind of a refresher, but you're really responsible to figure out how to 3D print these the best way possible. Like which direction are they going to be printed, where on the build plate, those types of things. So this is an example of the snap fit pivot, one of the many different movable connectors. So you could design this week, okay, send it to us, print 2 of them, and you could get it back and snap one together and make it rotate one around the other. Okay. These are dimensions and stuff that are not maybe not even relevant to our printers, but this is just an example. Now you don't have to draw anything other than produce this connector, and you could print something as simple as this and that and make one snap together and spin around the other. That's really the proof of concept that we're looking for. And you have to do that for 2 different types. So this would be one. A press fit might be another type of connector that you have. So this is a round hole and a polygonal pin that is touching kind of at the points. These are other types of zero clearance pin press fit type of assembly connections. I'm not going to go through all of them, but again, these are available in the information that we gave you, and you can decide which ones you want to use. Other things to consider when you're 3D printing is, and there are a lot, but these are looking at strength and durability because the toy's got to last. A real quick example of that is making right angle corners makes this piece easy to snap off. Whereas if you put a radius on it, that makes this piece much stronger and a much better design. So those types of considerations you got to be thinking about to make this as successful a process as you can, because if you make this part, it keeps breaking, then you end up wasting a fair amount of time when you could have done it much quicker by understanding some simple design principles. So a couple other things, you got to remember that there has to be clearances between the parts, and the clearances we've talked about, and it's been in some of the links. I'm not going to get into it, but you cannot make the parts the same size. It just does. The printers aren't that accurate. Here's another great point. You need to test as often and start as early as you can and test as often as you can. This process is going to take some time. So you need to be 3D printing this week with at least one of your parts if you're going to be on task, I think, to finish this thing properly. Make sure you're doing things dimensionally about the right size. If you try to scale stuff 3-dimensionally in a CAD program, it tends to be complicated. Okay, so I'm just warning you, don't start with a large, if I made my truck, for example, 15 or 20 inches, and then I tried to scale it down, there's going to be problems, I guarantee it. So try to be around the right size when you start to design so that you don't have problems later on. So again, just to remind you, prior to your WebEx meeting, after you've submitted your toy submission form, you have the toy submission form turned in. You need to submit all your sketches, however many there are. And you need to start designing your connections and getting them 3D printed by submitting that form. And I would say all of this should happen, or at least start to happen this week. Okay? And then you can sign up for your WebEx meeting. Again, the sooner the better you do this. This is going to take what we call many iterations, many tries. It doesn't usually happen the first time. Now remember, even though you're meeting with us this first time for an individual meeting on WebEx, we can meet as many times as you need help with. So don't feel like this is the only meeting we're having. We're not. If you want to meet daily, weekly, whatever you need to get this done, to understand it, feel free to sign up for those office hours, and we can help you out as much as you need. So this is the initial meeting to get you moving along and being able to not only print the connectors, but start making the parts so we can get those printed as well. Going forward, you can meet with us anytime. Again, this is just, remember, you got to stay within the requirements, 5 parts, all that stuff. So this is posted on Schoology. I'm not going to go over it again. So the process in summary works like this, and I'll post this sheet up on Schoology. But basically, the steps you need to complete to get this entire project done and make sure you get a decent grade. Start off with probably on Monday, today, if you're watching this video on Monday or the first day you see this video, is to complete the toy submission form. That's a Google sheet. Then you need to start sketching and get your sketches done. Take a picture of those sketches and get them posted and submitted to your teacher. That's done on Schoology as well. Then you need to schedule a WebEx meeting with your teacher, look at the office hours. Again, I would encourage you to get that done this week. If you get all that done this week, you'll be moving along pretty well. Again, if it doesn't happen until next week for some reason, it's fine, but you're going to be behind the 8 ball pushing forward. So then you're going to design. Again, this should be started this week. You're going to design and prototype at least 2 types of connections. You can send them to us. We'll start 3D printing. Don't wait around. If you design one connection on Tuesday and you send it to us, don't wait till it's done. You can design the other one and get that rolling so that we can keep sending you, and you can keep testing them and sending them back. And again, this process, I think, will go back and forth quite a bit. So you must prove, once you've got them done and they actually work, then you're going to submit a short video of them working. And you need to get that done, those two connections, before you can start designing an Onshape, your actual toy. Then you get to design and 3D print your parts. And obviously you're going to have to get them to fit as an assembly. So that starts to test things. So then the process for that starts to take hold. So by next week, end of next week, you should hopefully be starting to design your toy if you're on task and kind of where you need to be. Basically, you're going to turn in your 3D printed toy. Hopefully it works and it's all assembled and it has the moving parts it needs, and that is your semester grade. That's where we're headed. You'll also need to take a video of it moving, and that's more for your record. We'll give you the toy back, but we want to see the toy in person, and it has to be turned in. We will not accept a video of the toy. The video is really more for your own records, so you can show whether it's your college entrance or you're an employer, what you've actually been able to do and all that work and effort that went into designing this. Though it's called a toy, it's not an easy project. So lastly, this is my advice to you. The process from going from your sketches to computer-aided drawing your design on Onshape and to successfully 3D printing your toy is going to take time, patience, persistence, and many iterations. So the sooner you get going, the better off you're going to be. You cannot sit around and wait for your parts to be 3D printed. While you're working on submitting one part, you should be working on the other parts. Whether you're doing the connections, you should be working on both at the same time. Once the connections are a proof of concept, you got them done and you got the videos turned in, then you should be working on your parts for your assembly of your whole toy. And again, while you're printing, one part, you should be working on another and keep that rolling. That's kind of what I just said. You need to continue to print one part after another. So don't wait around, send your teacher a part on Monday and wait till it comes back on Wednesday. And you'll have to come into school to get them. We'll print them and put them at the front desk, and that's where you'll pick them up. If you procrastinate, you're going to run out of time. You remember, we got a couple weeks here before Christmas break. You sure can work on it over break. But coming back, the semester ends up about the 28th or 29th of January. So we get back, we have about 3 weeks, a little over 3 weeks, and that time will go fast. So make sure you get going right away. And again, this is even more true that procrastination is much easier when you're home by yourself. I know that personally. So make sure that you're getting this rolling and you're getting things taken care of so that you don't run out of time. All right, so that being said, I'm jumping back to last minute. If you have questions at any time, don't be afraid to ask. Send us emails, sign up for a WebEx meeting so we can make sure you're understanding things. If you're struggling with something, most of the stuff is on Schoology. Actually, not most of it, all of it's on Schoology. So you can always refer back to this if you're not sure what you need to do or the order you need to do it. But a lot of that same information we'll post as sheets on Schoology. Good luck, and if you need things, reach out to us.